Welcome to Ask and Learn.
All right, a little bit of algebra here in this problem, but the first step is to calculate the density of the shell. Okay, density of shell that extends from R1 to R2. And so density, if you remember, is just mass over volume. So density of the shell, rho sub h for shell, is mass of the shell, or is mass m, which is big M, over volume, which is 4/3 pi r cubed, and r in this case, and r cubed in this case will be r1 cubed minus r2 cubed, because we want the density of this stuff here, not anything inside or outside. So that's why we're taking the difference between the volume of this bigger circle and the volume of the, or bigger sphere and volume of the smaller sphere. Okay, so that's density of the shell. And so then what we have to do is find mass of the outer shell and the inner shell, or let's say mass mass of R1, right? So that would be the density of the shell. That would remain the same times the volume of R1 of the R1 sphere. So that's 4/3 pi R1 cubed. Therefore, you have you put in density of the shell, rho shell, which is m over 4/3 pi R1 cubed minus R2 cubed times 4/3 pi R1 cubed. And so the 4/3 pi's cancel, giving us m R1 cubed over R1 cubed minus R2 cubed. Okay. And then density of the inner shell, so that's mR2, or mass of the inner shell, mR2, is rho shell again times 4/3 pi R2 cubed this time. And so this will be in much the same way, m over 4/3 pi R1 cubed minus R2 cubed times 4/3 pi, it's a cubed over there, by the way, 4/3 pi R2 cubed. And so that gives you m times R2 cubed over R1 cubed minus R2 cubed. All right, so you've got those two masses. And then you're set. All you have to do is find U of shell, potential energy of the shell, which is UR1 minus UR2, gravitational potential energy at the outer shell minus gravitational potential energy at the inner shell. So this would be from the formula negative G times small m times big M over R. And so negative GM over times MR1 over R. And then that would be, let's look at, right. Right, so that would be negative 2, that would be negative GM, G small m times MR2 over R. And so you can see that negative GM over this distance R can be taken as common. So you have negative GM for R times MR1 minus MR2. Okay, and so what you get M sub R1 minus M sub R2. And so we plug those in from before, when you get U shell equals negative GM, or negative G times small m, I should say, over R times m R1 cubed over R1 cubed minus R2 cubed minus m R2 cubed over R1 cubed minus R2 cubed. And so again, we can take m outside, big M, and so we have negative GM m over R times R1 cubed minus R2 cubed both divided by r1 cubed minus r2 cubed. So this really turns out to be r1 cubed minus r2 cubed over r1 cubed minus r2 cubed, which is just 1. Therefore, we have that u of shell equals negative gm times small m over r. And we are done.